Bismillahirrahmanirrahim. Okay, next is question number 9. Previously we discussed number 5, so we skip the other question which is not much related to buck. So we go direct to number 9. Okay, number 9. So again, please draw the concept converter diagram. So write down all your input or the data. So we have resource of 12.6 volt, V out of 5 volt, then switching frequency of 20 kilohertz, and we have capacitor provided of 470 microfarad, capacitor microfarad. Inductor also being provided with 10 millihenry values. Okay, the things that we don't have now is what? Duty cycle R. Okay. Okay, now the question is that for output load 0.2 ampere. So for this 0.2 ampere, how much D that we need? And output ripple. Output current here, calculate the D, and the output ripple voltage. Ripple voltage means that this is ripple voltage, not ripple factor. Ripple factor is delta V out over V out. So this is ripple factor in percent, X percent, let's say. But ripple voltage is this part only. Okay, ripple voltage is that delta V out, which is in Vx volt. So that's why we have here this ripple voltage. Means that if you probe your output voltage, you have a swing like this, same like what you have in capacitor. So this is in inductor. So this is, let's say, your voltage output. So this is V out. So when you zoom in, you shall have a ripple. So V out max. So this is V out minimum. So delta V out is equal to V max minus V minimum. So this is your ripple voltage. Mana hilang dah. This is your ripple voltage. Okay. Okay. So we start the calculation. So we have already all the parameters here. So we need to find our value of D and R. So let's say we find out for D first. So D is equal to V out over Vs, which is 5 divided by 12.6. So it becomes how much? 0.397. 0.397 of the duty cycle. Okay, for another part which is our R. So we have P equal to V square over R, or R is equal to V square over P. Or we have another formula which is P equal to V I equal to VI, but still we don't have here the P. We have only what? What else we have here? So we have only V and I. Okay, current given. So we can use the formula of V equal to IR. So you have to jot down all the formula and use where necessary. So we have here V equal to IR. So R is equal to V over I, which is V is here 5, I is here 0.2. So the R is equal to 25 ohm. Okay, this is the R value at this output. P out at V out at I out. So this is our values of R. Okay, we obtain for R, we obtain for D. Next, how much the so L given, C given. So what we need to find here is IL mean, and IL mean to confirm that is it working in CCM or not. So to check does it work in CCM or not, because we have to use the formula for CCM to calculate for the values of C. So IL minimum is equal to V out 1 divided by R minus 1 minus D over 2 LF. Okay, all the provided data we put in here. V out is 5 volt. I over 25 minus 1 minus 0.397 divided by 2 times 10 millihenry times 20k. So equal to 5 times, we solve one by one, accordingly. So calculate for 1 minus divide by 25, so you get 0.04 minus, solve the right hand side of equation, so we get 1.5 milli. So 5 times 0.385. So we get the final answer of IL minimum of 0.192 ampere, which is for sure it is positive value. So this is CCM mode of operation. Okay, so means that our circuit is confirmed to work in CCM. So with this CCM assumption, we can calculate for our inductor value, for capacitor value. So the formula is that delta V out over V average output is equal to 1 minus D divided by 8 LCF squared. So for C is equal to 1 minus D divided by 8 times L times delta V over V times F squared. Okay, then you insert all the information that you have calculated. 1 minus 0.387 divided by 8 times L. L which has been provided 10 milli times your delta V. Okay, sorry guys, we're not going to search for C because C is already provided. We need to look out for delta V. So the delta V should be the things or the parameter to look out for. So it should be like this. So delta V to be equal to V out 1 minus D divided by 8 LCF squared. Okay. So we have V out here, which is 5 volt. 5 volt. 1 minus 0.397 of duty cycle divided by 8 times value of L of 10 millihenry. C C is 470 microfarad, and frequency of 20 kilohertz squared. So if you calculate, you shall get your value of, so you solve first the upper part, divide by the lower part here. So you shall get your delta V out of 0.2 millivolts. So 0.2 millivolts. So this is your ripple value. Delta V out over V is ripple factor in percent, but in value, so this is your answer. Okay, thank you very much. Okay, that is the answer for question 9, number A. So the output voltage ripple, so 0.2 volt. Now we go to B part, which is the question is that how much the duty cycle we need to set if the load current reduced to 0.05 ampere. So for this part, we have to calculate in terms of their, we have to confirm their CM or DCM first. So IL mean IL minimum is equal to V out times 1 over R minus 1 minus D divided by 2 LF. Okay, or V out over R minus V out times 1 minus D divided by 2 LF. So this is our average output of load current. Okay, remember not? So I L equal to V out over R. And so this is your average load current. So you can include your values here. V out has 5 volt. R value is 25 divided by 5 times 1 minus D. We try to check is it still in CCM or DCM. Divide by 2 times L, which is 10 millihenry. 10 millihenry, frequency of 20 kilohertz and 20 K. So how much you get? Which is one? So if there is that, so you shall get 0.04 ampere, which is bigger than 0, so it's still in CCM, alright. Okay, means that your duty cycle is the same. So your duty cycle is the same of 0.397 because the operation still in CCM. So it does not change. Your operation of this converter is the same at CCM, so the duty cycle is maintained at 0.397. Okay, that's all for question number 9. So other question I will upload and alert you again. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.